Okay, boys, previous lesson we have studied permutation of n elements from n elements. It means if we want to arrange or order all elements of a set. This lesson we will study if we want to arrange some of the elements of total elements of a set. For example, if we choose all elements which r is greater than or equal to 0 and less than or equal to n, it can be 0, it can be n, but between these two are also possible. So in this case, what should we do? Or what's the permutation of all elements selected from n elements? How can you calculate it? So in this case, the permutation of all elements selected from n element is equal to n factorial over n minus r factorial. For example, how many different two letters combinations can we form the letters of the word Kano, K-A-N-O, if a letter cannot be used more than once? Yeah, this is a condition for permutation. If it can be used for twice or it can be used more than one, it can be repeated. So in this case, it will be changed. Okay, now two letters permutation of two letters from 4, because the total number is 4, is equal to 4 factorial over 4 minus 2 factorial, which is equal to 4 times 3 times 2 factorial over 4 minus 2 is 2 factorial, so 2 factorial, 2 factorial cancel, and it's equal to 12. It means we have 12 different permutation or arrangement for two letter words which can be formed from K-A-N-O letters. For permutation, we can use different notations. For example, this is one of the other notations, permutation of R elements selected from n elements, or permutation of R elements selected from n elements to mean this one, as we used in previous example. Now let's calculate permutation of 3 elements from 5 times permutation of 2 elements selected from 7. Let's calculate them. Let's write the permutation of 3 elements from 5 is equal to 5 factorial over 5 minus 3 factorial is equal to 5 times 4 times 3 times 2 factorial over 2 factorial over 5 minus 3 is 2 factorial, 2 factorial, 2 factorial are cancelled. I'm sorry, are cancelled. So 5 times 4 times 3 is equal to 60. And also a permutation of 2 from 7 is equal to 7 factorial over 7 minus 2 factorial is equal to 7 times 6 times 5 factorial over 7 minus 2 is 5 factorial, 5 factorial, 5 factorial cancelled, 7 times 6 is 42. If we multiply them, so permutation of 3 from 5 times permutation of 2 from 7 is equal to 60 times 42, which is equal to 2,520. Next example, permutation of 3 from n times 5 is equal to permutation of 4 from n. It's given. The question asks us to find the value of n. So let's find it. Permutation of 3 from n times 5 is equal to n factorial over n minus 3 factorial times 5, and it's equal to a permutation of n from 4, 4 from n is equal to n factorial over n minus 4 factorial. We can simplify n factorial by n factorial, or if we divide both sides by n factorial, we can simplify it. If we multiply both sides by n minus 3 factorial, we will get n minus 3 factorial over n minus 4 factorial will be equal to 5. N minus 3 factorial is n minus 3 times n minus 4, n minus 3 times n minus 4 factorial over n minus 4 factorial, n minus 4 factorial, n minus 4 factorial is equal to, cancelled, is equal to 5. So n minus 3 is 5, so n is equal to 8. Another example, how many three-digit numbers can be formed from the digits in the number 1, 3, 5, 6, 7, or 13,567 if a digit cannot be used more than once. It means if we want to form three-digit numbers, so we should select 3 from these 5 digits. So permutation of 3 from 5 is equal to 5 factorial over 5 minus 3 factorial is 2 factorial, and is equal to 5 times 3 times 5 times 4 times 3 times 2 factorial over 2 factorial, 2 factorial, 2 factorial cancel, and is equal to 60. So we can form 60 three-digit numbers from these 5 digits. Okay, next example, 3 raffle tickets, or we can also say lottery tickets, will be selected in order from a box containing 30 tickets. The person holding the first ticket will win a car. The person with second ticket will win a computer, and the person with the third ticket will win a CD player. In how many different ways can these prizes be awarded? Again, we have a totally number or 30, so we choose 3 of them. So again, permutation of 3 from 30, and it's equal to 30 factorial over 30 minus 3 factorial, and it's equal to 30 factorial over 27 factorial. 30 minus 3 is 27. So it's equal to 30 times 29 times 28 times 27 factorial over 27 factorial, 27 factorial, or cancel. So 30, it's equal to 30 times 29 times 28. We can choose, or these prizes can be awarded in 30 times 29 times 28 different ways. Next one, Kamal's bookcase has 3 shelves. Kamal has 5 different math books, 6 different biology books, and 7 different physics books. 5 math, 6 biology, 7 physics. He wants to arrange 3 math books. It means from 5 he wants to choose or select 3 of them, and 4 biology books. From 6 he choose or he select 4 of them, and 5 physics books. From 7 he select 5 of them on the shelves, so that each shelf is for one subject only. You cannot arrange the physics books among the biology or math books, or so on. And how many different ways can Kamal arrange his books? First of all, we have a permutation between each subject. It means permutation of 3 from 5 for math times because in here for different subjects we have different ways, or our task has different parts, so we should use multiplication principle, and permutation of 4 from 6 for biology times permutation of 5 from 7 for physics, permutation of 5 from 7, and also we have an arrangement between the shelves. Also we have different orders for shelves also, so we have 3 shelves, so there is 3 factorial different arrangement between shelves. So this one is the arrangement between the box that he can do it. If you calculate them and multiply them, you can find the total number of ways that Kamal can arrange his books. Yeah, next example. A three-digit number is formed by choosing elements from the set 1, 3, 4, 5, 7, 8, 9. It means totally we have 7 digits in here without repetition. Yeah, in permutation we don't have repetition. If we have repetition, in this case we should use different way. Uh, First case, how many numbers do not contain the digit 5? It means take out 5. If we take out 5, so the total number of digits will be 6 in this case. 1, 3, 4, 7, 8, 9. And we want to find 3-digit numbers or select 3-digit numbers. So permutation of 3 from 6 in this case for A case will be considered. So it's equal to 6 factorial over 6 minus 3, 3 factorial, and it's equal to 6 times 5 times 4 times 3 factorial over 3 factorial, 3 factorial, 3 factorial cancelled. So if we calculate them, we will get 120 different ways, or to 120 three-digit numbers do not contain 5 digit or the digit 5. Second case, B case, how many numbers contain the digit 5? In this case, we find the total number of digits and subtract that number of numbers which do not contain the digit 5. So permutation of the total number is permutation of 3 from 7 in this case, the total number, minus permutation of, if the numbers do not contain digit 5, the permutation of them will be permutation of 3 from 6, because we take out 5 in here. So it's equal to 7 factorial over 7 minus 3, 4 factorial, minus, it's the total number of 3 digits, which can be formed from these 7 digits, minus, and this one is permutation of 3 from 6, or the numbers which do not contain 5. If we subtract them, so we will gain or obtain the number of that numbers which contain 5, minus 6 factorial over 3 factorial. I'm sorry. So it's equal to, if we calculate them, we will get 7 factorial 210 minus, and we calculated in previous example, minus 120, and it's equal to 90 numbers. It means 90 numbers, 3-digit numbers of course, contain 5, but 120 numbers do not contain 5, and the total number of 3-digit numbers are 210. The C1, C case, how many numbers contain 1 or 7 or both 1 and 7? Again, we do the same way or the same thing which we use it in case B. We find the total number of 3-digit numbers and then subtract that numbers which do not contain 1 or 7 or exclude 1 or 7. So if we take out 1 and 7, so how many digits will be left? 3, 4, 5, 8, 9. It means 5 digits will be left. So permutation of 3 from 5 is, or the total number of that numbers which do not contain 1 or 7, or that numbers which excluded 1, 7, or both of them. So let's do the same thing. Permutation of 3 from 7 minus permutation of 3 from 5. This is the total numbers, 3-digit numbers. This is the number of that numbers which exclude 1 or 7 or both of them. And it's equal to, if we calculate this one, this permutation of 3 from 7 is 210. And if we calculate the permutation of 3 from 5, it's 60. If we subtract them, 150 numbers will be left. It means the total numbers which contains 1 and 7 or both of them is 150. Check yourself 7 or the exercise 7 in your math box. your homework about this subject.